So this is the 2016 higher level question B1. It's looking at surfaces and the angles that are formed between them. So some of the stuff that we've done in this is related to the oblique plane. You'll see stuff that was related to geologic geometry inside in it, with the dip, the strike angle, stuff like that. So all of this is interconnected, and I'm just going to go through this question as it relates to something that appeared in the pre, and also it's going to help us when we come on to surface geometry, which is the next topic that we're going looking at. So just a few things that need to be recapped on. We're looking at the dihedral angle. So the dihedral angle is going to be the true angle that is formed if you have two planes, two roof structures, something like that. What is the real angle that is between them? So when we see an edge view of it, I can have it something like this, or something in here like this. Each one of those, that's the dihedral angle between both of those surfaces. So let's have a look at the question. The image on the right shows the restaurant, which consists of a series of intersecting triangular glass surfaces. Figure B1 shows the planned elevation of 4 such intersecting planes. The data relate to the horizontal and vertical coordinates for points A, B, C, D, E, and F. Defining the 4 planes are also given. So this is like the question that appeared in your pre. So we have A, B, C, D, E, and F. We're missing a small bit of information for F, but that's part of a later question. Each of those numbers relates to the coordinates. So A is its x value, so that's how far it is from left to right on the page. The 130, the 40 is how far vertically it is up off the ground, so that's going to be a height. And 80 is going to be the distance it is out from the wall, so essentially how far in plan it is from your XY line. So we'll have a look at that just for one moment. So point A is 130 millimeters, so pick a random point off to the left hand side of the page. In 130 gives me the distance left to right of point A. Point A, we're then told, is 40 meters or 40 millimeters above the ground, so that's going to be at 80 here. And then we're also told that it's 80 millimeters, that's its distance out from the back wall. So in our XY line, what that's going to look like, or in our plan, that's going to be the distance out from the XY line. So this is point A in the elevation, this is point A in plan. B, C, D, E, and F are all completed the same way, but we'll just have a quick look at the question again. So B, we're given coordinates for that one, so we can put those into it. C, D, E, and F. F, we can find some coordinates. We'll be able to find how far it is from left to right on the page and how far down it is in plan. We don't know how high off the ground it is in the elevation. Looking at the questions, part A is draw the given plan of the 4 triangular planes and complete the elevation of the intersecting planes. ABC, ABD, and DEB. So we're ignoring the one with F in it at present. Part B of that is determine the dihedral angle between planes ABC and ABD. For that, we're going to need a true length of the line of intersection between the 2 planes, which will be the line AB. Part C is draw the elevation and plan of a horizontal line on the surface DEB, and then determine the true inclination of surface DEB to the horizontal plane. That essentially is the strike and the dip that you see inside in geologic geometry. Horizontal line will be drawn from E in the elevation. You'll draw the same line in plan, look along it. It's essentially the strike that you have in geologic geometry. Part D then is the dihedral angle between the planes DEB and DEF is 170 degrees. Complete the projections of the surface DEF. So what that's going to give us is point F in the elevation. So all I've done here is skip forward a little bit. I've located each of the points and still find E. So it's distance from the left hand point that we picked first. Swap back to that. So starting point off over here on the left hand side. It's just in about 2 centimeters from the left side of the page. And each measurement then that we're given across. So E is going to be measuring from this point, always measuring from the same start point. E is in 210 millimeters. It has an altitude of 70. Altitude is 70, and it's a distance of 25 millimeters out from the back wall. Okay, so this is E, and F then is going to be much the same. So again, starting from the same starting point off over on the left hand side, and coming across here at 23. I don't know how high it is off the ground. It's going to be up here somewhere, where I don't know. We'll locate that later on. And then in plan, it's a distance of 55 millimeters out from our back wall. So this is F. So this is the elevation and plan of each of those points. Now what I need to do is I just need to join up each of the planes together. So I've got a plane ABC. So joining all three of those up together in elevation and plan. DEF. So all I've done now is just skip forward a little bit so that you're not watching 40 minutes of nothing. Joined up all four of the triangles in plan. In the elevation, I still don't have a point F, so I can't draw that one up here. So the next part of this now is we're going to look at drawing the, I'll just have a look at the question again. So draw the given plan of the four triangles and complete the elevation of the intersecting plans ABC, ABD, and DEB. So part A of this is done. Next part of this is determine the dihedral angle between the planes ABC and ABD. So dihedral angle between ABC and ABD. So to start off with this, the dihedral angle, as I said, is the true angle that is going to be between two planes. So I could have a plane that's looking like this or like that, but I need an edge view of the line of intersection between those planes to solve it. To get an edge view of something, you first need to have a true length. So if I want to look along a point view of something, I first need to be looking in perpendicular to the line first and have a true length of it. So I can do that in the elevation or the plan. Generally it's easier to do it in the plan because that's what we're more familiar with. So what we're going to do is we're going to look in perpendicular to the line AB, as that's the line of intersection between both planes. So all I'm doing is taking an auxiliary view. I'm going to look in at this direction and project my lines off out along here. So projecting an auxiliary view, 1 and 2, and it's going to be out along here. I can draw an XY line. So this here is my X1, Y1 line. X1, Y1 line. Now for each point here we have A, B, C and D. Each of those need to be projected out into this view. The handiest way of doing that is taking points, each point out and projecting them out along. So that's D, B is going to be out along here, C here also. Now this view here is an auxiliary elevation, so I'm going to take my heights from the elevation. So each of the points here I'm going to take the distances or the heights that they're in the elevation. So this is one view, skipping this view, measuring from up here. So point A, going to take the height that is off the ground up in the elevation and mark that along the line for point A up here. So this is point A. It's important that you label these as you go so you're not getting too confused with it. B is the same, so B is on our XY line, measuring the height that it is above the ground. And this is line B. C, taking the height, it's the same height at C, and D then is at this height. Okay, so extending my lines on. This is C, this is D, and up here is B. Okay, so join the planes up again as they were. So you've got ABC and ABD. So ABC is this plane, and ABD is the second plane. Now what's important that I have here in this case, because I've looked in perpendicular to it, I now have a true length of the line of intersection between the two planes. So this line here is a true length. Because it's a true length, I'm now able to look along that line. So I can look along this line here, and that's going to give me a point view of the line of intersection. And as it's going to be a point view, I'm also going to see an edge view of both surfaces. So again, I'm going to look down along this way. So I'm going to look along the true length line, projecting each point down along. And again, I'm going to have an x2, y2 line. So x2, y2. Okay. Now, just like our rule was the same in the previous one, we're going to do much the same here again. So, as I said when we were measuring something, you're always taking it from skipping one view and then going back one more. So this is a second auxiliary view. It's projected from this view, so I'm going to take my measurements from here. So one view, skipping this one, measuring from here. So each distance that we're going to measure from is our x1, y1 line, and it's going to measure back to the corresponding point. If you like, and what I'm going to do, I'm going to use a measuring line instead, just so that it's not so far away. Now my measuring line, it's all I'm basically doing is moving my x1, y1 line back a little bit closer. Okay, so I can put it on point C. It's probably the handiest place to put it. And I'm just calling that ML, measuring line. So what I can do here then is I can measure the distance from my measuring line back, because I will run out of space down here otherwise. If this was on the larger A2 sheets, it'd probably be okay. So point C now is sitting on the measuring line. So if it's going to be sitting on the measuring line, it's going to be on the x2, y2 line over here. Point A and B, as it's parallel to the x1, y1 line, they're going to be the same distance back from the measuring line. So I can measure my distance here. So measuring line to A and measuring line to B, they should both be the same. Okay, so there will be a singular point here. So this is C, this is A and B. And then we can also measure from our measuring line back to D. So here is D. Now what we have is an edge view of both surfaces and the line of intersection between them. So that is one surface, that's the surface ABC. This is the surface ABD. And we're asked to find the dihedral angle between the two. This angle in here is the dihedral angle, and when measured gives us an angle of 167 degrees. So in here is dihedral angle, and that equals 167 degrees. So what I've done here is I've first taken an auxiliary view of the line of intersection. So that's the line AB for these two planes. I take my auxiliary, I measure my heights from the elevation. That's going to give me the true length of this line. Once I have the true length of the line, and I've also found the other plane, the points on the plane up here, I will look along the true length, and looking along a true length line is going to give me a point view of that line. Okay, so that's going to be this point here. Each point then I'm projecting down into the second auxiliary, and I'm going to take my distances from the plan. So this was my second auxiliary, skipping the auxiliary elevation and taking my distances from the plan. So I can measure from the xy line back to each point. So x1, y1 line to A, x1, y1 to B, and so on. Or in this case, I just shortened it up a small bit and I put in a measuring line. This measuring line is parallel to the x1, y1 line, so all I'm doing is reducing removing that much distance off my question. It's just so that it fits on the page. Okay, so that is the dihedral angle. Determine dihedral angle between the planes ABC and ABD. So now if we have a look at the question again, we've done part A and B. Part C of this is to draw the elevation and plan of a horizontal line on the surface DEB and then determine the true inclination of the surface DEB to the horizontal plane. If you read that and if you look at any one of the geologic geometry questions, question C1, drawing a horizontal line, that's how we start when we find the strike of something in plan. So if we're asked to find the dip and strike of a question, this is essentially what we're being asked to do. We draw a horizontal line in the elevation, we find that same line in plan, and then we look along it. Okay, so this is essentially finding the dip and strike of the surface DEB. So let's have a look back at the board again. So this is DEB, that surface. This is the same surface down here in plan. And we're asked to draw a horizontal line on the surface DEB and then determine the true inclination of the surface, the horizontal plane. So I'm going to take a line up here, a horizontal line, and I'm going to do that. It's going to be in the elevation, because that's the only place I'll be able to see if it's horizontal. So DEB, I'm going to take a horizontal line from the middle point. Okay, so this is a horizontal line. So just zoomed in on that a small bit just to make it a little bit clearer. Now what we need to do is we need to find that horizontal line down in plan. And we're going to do that the same way we've been doing it in geologic geometry, where it intersects the line BD. That is the same point down here in plan. So I can join this point up to E, and this is the horizontal line, what we would normally call in geologic geometry the strike. So what we're going to do next is we're going to look along that line in the same way that we do it in geologic geometry. So we're going to, if we look along this line, and I'm going to project out all points on the surface DEB. This is projected out, point B is also projected out, and point D. Again, I'm going to draw an x1, y1 line, so where this goes does not matter. So I'll just keep it in a little bit closer. So this is x1, y1. I'm going to project each point out along here. So the point is going to be taken from as it would in geologic geometry, the height that it is in the elevation. So point D, I'm going to measure how high that is off the ground. This is height for D, mark that up. Do the same thing for E, which also gives me the height for the horizontal line. That's this point. And also measuring up the height for B, which is up here. That's this height. So this is E and the horizontal line. This is B and this is D. Joining all of these up, we should get a straight line. Okay, so that's the edge view of that surface. Now what we need is the true inclination of the surface to the horizontal plane, essentially the dip. So I'm just going to extend that plane on until it touches our x1, y1 line. And this angle in here, that's the angle that we're looking for. Now if we measure that with our protractor, we end up with an angle which we need to write on it. So lining it up with 0, we end up with 51 degrees as the true angle of that plane to the horizontal. So just to recap on part C of this question, we were asked to draw a horizontal line on the surface of BDE, which is what we do for our dip and strike. Finding that same horizontal line then down in plan, so that it gives me this line. It's It's going to be a true length as it's horizontal in the elevation. And if we look along that line, then we'll be able to see the true angle that that plane is inclined at to the horizontal plane, what we call the dip inside in geologic geometry. Alright, so we're just going to have a look at the final part of this question, which is the dihedral angle between the planes DEB and DEF is 170 degrees. Complete the projections of the surface DEF. That's part D of the question. So basically what they're trying to find is we need to find where point F is up here. We're going to use some the information or the knowledge that we got from part A or B of this question, where we figured out that this is 167 degrees. We're basically going to do this in reverse. So we're going to find the true length of the line of intersection between both of them, just like we did up here. So we're going to look along the line DE, just like we looked along AB a while ago, and that's going to give us points out along here. Again, we're going to find the true length of that line, so we'll take our heights from the elevation and mark them out here. That's going to give me a line here. We'll find B. We won't be able to find F just yet, but we will know that it's out along here somewhere, and then we'll have a look at drawing the correct angle. So I'm going to start off by looking doing what we did when we were finding the first dihedral angle. We're going to look along the line DE. So I'm going to project along both of these lines. So projecting D out, B, F and E, projecting each one of these out. I'm going to draw an X1, Y1 line again, so that X1, Y1 line can go anywhere out here. Doesn't matter, so this is X1, Y1. And I'm going to measure each distance from the XY line in the elevation up to the point. Now it's best not to put in a measuring line in this case for this question, because we don't know where point F is and it could end up being behind the XY line. So it's better just to measure from your XY line the height up for each point. So measuring up the height for D. So measuring from our XY line up to D, marking that in the auxiliary view. Doing the same thing for point B. So we have that height. Now you can always, if you don't want to use your compass to measure it, you can always just take the height that was given in the question starting off. So that will be the second number. So if we were to take point B, that's up at an altitude of 85, and that was given in the question. For E, again, you can measure with your compass, take that height and mark that up over here. And F, we don't know how high up it is, but what we do know is it's going to be somewhere out along that line. But most importantly now, what we've done is we've now found the true length of the line DE. So this is the true length of the line DE, because we looked in perpendicular to it, so we looked in perpendicular that way and found that. And then I also found what point B looks like out here somewhere. Okay, next part of this is we're going to look along the line DE. So we're going to look along the line out along here. So getting an edge view of it, or point view of it, looking out along that way. So I'm going to look perpendicular to that now. Okay, so I'm going to have an X2, Y2 line here. Projecting each of the points out along. Now we're going to measure, we're going to skip a view and measure back. So if I'm going to take the height of now I'm just going to run out of space here on the right hand side of this, so I'm going to put in a measuring line. My measuring line is going to go on F this time, and I can use it in this case at this point. So again, I'm putting in my measuring line. So my measuring line is going to go through point F. This is my measuring line. So what I'm going to do from my measuring line, I'm going to measure the distance back to each of the points. So from measuring line back to B, that is going to be this far. I'm going off the board. measuring line back to D and E, which will be in the same position. So D and E. And F is going to be somewhere along that ground line. I don't know exactly where. What I do know is though that the angle between the 2 points, or the 2 planes, is going to be 170 degrees. So this is one plane, just like we had the plane over here. What I'm going to do now is I'm going to measure 170 degrees from this plane. Okay, so if I measure 170 degrees this way, so that'll be here, and then I can draw in that plane. So where that intersects here, this is 170 degrees, and this is point F. How I know it's point F is because I put my measuring line here. If I didn't use a measuring line, it would be wherever the line is up this height. Okay, so it would be intersecting up there somewhere. So just like D was up this height off the ground, D and E, F is now this height off the ground. So I'm now able to project that back. So if I project my lines back into the auxiliary elevation, so I'm projecting that point back, that's going to intersect the line F here. So this gives me point F. So that's where they intersect each other. I can take that line back to here. And then that's almost the question complete. What we need to consider here is what can I do with this bit of information. So this is point F. How did I find the position for D out here? I measured from the x1, y1 line to D. Where did I get that height? I got that height from up here. So x1 or xy to D is this distance. Xy to B is going to be this distance. So if this is xy to F, that means that this height here is going to be the height that I'm looking for over here. So I'm working in reverse. I'm taking the height F. I'm going to mark that up along the line directly above F over here. And that gives me the projections of point F up in the elevation. So this is point F. So that height that we got there is found from this piece here. So this height, got it here originally and then marked it up over here in the same way that I got the height for D and put that up over here earlier on, working backwards. So just going to talk about some of that bit again. I start by my dihedral angle question the same way that I did over here. I look perpendicular to the line DE, which is the line of intersection between the 2 planes. I find the true length of the line DE out here in my auxiliary elevation, and I'm taking the height D off the ground. Taking the height D is off the ground here and putting that over here. Taking the height E and putting that up over here. Once we have our edge view of the plane, I have E and point B just off the page. And then I can project this, I can measure the angle that I need coming back in along here. So this angle here is going to be 170, and that intersects with the ground line. It only intersects with the ground line because I used a measuring line. If I didn't use a measuring line, it would be intersecting with the height or the distance that this is back. Okay, so all I've done is remove that much distance off each of these positions out here, just so that it fits in the camera. Where this intersects, I'm going to project that back until it intersects with the line coming out from F, in the same way that E comes back and intersects with the line here. And same for B coming back in, that intersects with the line B out here. So where they intersect is going to give me that point. Finally, point F is that height. This is our auxiliary elevation, so it's a height. I can transfer that off up here, and that is my completed question.